Hey guys, welcome back. So today I'm revisiting this Yamaha inverter generator. Recently I made a video on this. If you missed it, I'll sum it up real quick. Someone had thrown this away at the dump, so I brought it home knowing nothing about it. And initially I thought it was a compression issue, but I put the compression tester on it and the compression was fine. So I fed it some fuel, tried starting it, and it started and the engine sounded good, but it was apparent we had some issues with the power output. I'd say about 50% of the time after starting it, there would be no output at all. And even when there was, the output was pretty poor. You could see it in the drop light I had hooked up. It was flickering and clearly something was wrong. So I ran a bunch of tests trying to eliminate every possibility except the inverter. And by the end of that video, I thought I had tested everything and proven that the inverter was in fact bad, but I've thought of a few more things to check, which I omitted. And I think it's important I check those because I do want to try repairing the inverter. But before I go to that trouble, I want to be sure that it is in fact the inverter. So let me get you set up a little bit better. We'll get these covers back off and dig in. So the first test I missed here was checking each of the coils to make sure they're not connected to ground. That is a common problem when there's an insulation failure and should be checked anytime there's a power issue. So I'm going to connect up to the three-phase output. There are 3 yellow wires here in this connector, and they're connected in a Y configuration. So technically, by testing 1, you are testing all 3 to ground. And there's no connection to ground. So we seem to be good there. Here we have 2 orange, 2 blue. This is the single phase output. The blue wires, they just get rectified to DC, and they feed the output on this control panel. But the orange are the ones I'm most interested in. That provides the low power to the inverter module to control the circuitry. And I'm very suspicious of that because, I know a lot of people suspect these caps are bad, but even if they are, these are used on the high voltage side of things. The low voltage side should still have control of the inverter, which controls the throttle and the status lights. And at times when I was getting no power, there was no throttle control, no status lights. So this inverter on the low voltage side has issues, or it wasn't getting power. So let's check the orange wires to ground. No issues there. We'll check the blue. No issues there. So it doesn't seem like there's an issue. What I want to do now is to get this thing started again. I'm going to probe the voltage out on the orange coil. And I also want to hook up some meters to the outputs on the front and just try to get a better visual as far as what's going on. So I've got quite a few things hooked up here. I guess first off and most importantly, I have these wires here back probed on the orange where it comes out of this control box going into this panel. So I've got the meter set to AC. I want to see that that's between 12 and 24 volts. We've got this meter hooked up to the DC output, and we have this meter and this oscilloscope hooked up to the AC output. So I'm going to try to get this thing started. The carb does have issues. It's flooding over, so I filled up the bowl. Once I get it started, I'll turn it on. Hopefully we get this to power up at least one more time so we can see what's going on. All right, 20 volts out on the orange wires. 21 volts on the 12 volt circuit, which is fine. There's no battery connected. AC output, 79 volts. You can see we're missing part of the sine wave. It's at 60 hertz though. So the fan's trying to spin, and the heating element's starting to glow. Shut that off. Well, that, I think, told me a lot. The space heater was on. You know, I saw it, the elements glowing, but the fan's not spinning. That fan requires AC. And according to the oscilloscope, it looked like AC, but we had a pretty flat spot where it wasn't inverting at all. So it was almost like pulse width modulated DC with a little bit of AC mixed in. Definitely wasn't a clean sine wave, and that was enough to cause issues with that fan, but it could still heat because that element will work on AC or DC. So there is an issue. I think the other thing, which I should have focused on because it just shut off, is that when I shut this generator off, the AC light stays on for about a minute, which is unusual behavior. That is controlled by the low voltage circuitry of the inverter, and I don't think is normal behavior. So, you know, the voltage going into the inverter, the 20 volts AC, is good. That AC light staying on after shutdown is strange. And the fact that we're missing part of the sine wave, not on both sides, tells me that more likely we have a control issue or some blown MOSFETs or transistors. So it's not going to be as simple as cutting off those capacitors, pulling the guts out, and locating some new capacitors remotely. That board actually has to be depotted. And I have received an offer from a subscriber to do that. So I may give him the chance, but I think he was under the impression that it was the caps. I'm not sure he would want to dig any further than that. And as it turns out, it may not matter because one of these inverters just went up for sale on eBay, one of these modules. The part number doesn't quite match the parts diagram, but when looking at it, I can tell it is the correct inverter, 100%. And supposedly it works. Now, it's not cheap. It's $480, but that's still a third of the price of a new one and quite a bit less than what this machine is worth up and running. So I'm going to try to win that. It is an auction. There's about a day left on it, so hopefully it goes well. Turn you back on in a second. I'm happy to report I won that inverter module and thankfully did not get in a bidding war. So the starting bid was $480, and that's what I paid for that used working inverter. So that'll be here hopefully in a few days. Also, I inquired to the seller if he had any more parts, and he did. He's actually parting out an entire machine, which is good because I am missing the battery tray as well as the cover for the inverter module itself. So he has both those parts. Also, the battery has been giving me trouble. It's actually been losing its charge after a few days, so I do need a new battery as well. And those three parts, new, would cost about $250, but he agreed to sell me his for $60 plus shipping. So got another good deal there. All that stuff's on its way. And while I'm waiting for that, I do need to address a few items that I've been ignoring. I guess first off, the carb, although it runs the engine fine, it is flooding over. So the needle and seat aren't playing nice. I'll take a look at that. There is a critter nest in there that has to be cleaned out. The oil is some of the blackest oil I have seen, so it's going to have to be changed several times. We'll start with one change now. And then lastly, this green pilot light. It is broken, although it still lights up. If I push it, it'll just fall right in. So I'd like to try to address those issues now. And then once that inverter gets here, we'll drop it in and hopefully be good to go. Wonderful. No air filter, so we'll add that to the list. The only reason I'm even opening this is because it's flooding over. It's running the engine quite well, so I'm not expecting to see much. So I'd say at a minimum, we do have to deal with the needle and seat. You know, maybe it is a lot worse, but I won't know until I get it opened. Now, one thing just to note on this carburetor, really any carburetor from an inverter generator with a servo, is that the servo is not connected directly to the throttle plate. Instead, there is a plastic piece. You can just see it right there that the servo connects to. And that piece has a spring. And really the only thing holding this all in place is the servo installed on the top. And since that's not there, this piece theoretically might be able to come off the shaft, and then it's going to launch that spring across the room. So take note kind of the orientation of the spring and this plastic piece in case it comes flying out. You might have to reinstall it. And in some cases, you can't remove the servo without removing this whole bracket. And then that piece is definitely going to come out. So just take note and you should be fine. Yeah, there's dust in there. So that's probably what the issue was with the needle and seat. There's probably just a little bit of debris, but you can see the carburetor itself looks very clean. So let's just get this pin out. We'll get the needle out, take a look at the seat, see if there's anything obvious there. Yeah, I'm going to need to tap that a bit. I don't see any issues with that seat. Looks spotless. And the needle, it's not terrible, but I wouldn't say it's perfect either. All right, to test the function of the needle and seat, I just hooked up a fuel line. I'm going to blow through it. Like this, you should hear no air going through. If you hear anything, it's going to leak. Let's try it out. Yeah, that's an issue. It seals sometimes, but not others. So let's get this off again and have another look. Yeah, it's coming out pretty clean. Yeah, there might be a little bit of a ridge there. That could be it. Let's just try it again. See if there's any change. I think that may have done it. I loosely put this carb back on the studs just to keep it level. And I connected a fuel supply and turned it on. It's been about 20 minutes and no leaks. So I think we're good. I'm just going to disconnect the fuel supply now and reinstall this properly. So I don't want to just install the servo back onto this carburetor. This wire harness leads directly over to the inverter, and it has to be removed in order to install the new inverter. So I'm going to remove this cap, which should expose the connector to the servo motor. Then I can just remove the harness, and that should be good for now. I can reinstall it like this. I'll leave the cap off, and then we'll finish up the wiring once the new inverter shows up. Just need to line up this piece here with the plastic piece on the throttle plate, and then it should drop in. Like that. Had to switch screwdrivers. These are JIS screws, and the Phillips was fitting, but I couldn't tighten these. It would just keep slipping. So JIS screwdriver fits these much better. And that should be fine. As far as the position of the throttle, you don't want it closed, because when you go to start it, you're not going to be able to start it like this. Service manual does say keep it full open, and then as soon as it starts, the servo will take over and moderate the speed. In this case, I'm going to go somewhere in between. You know, you just don't want it all the way closed because it won't start. And that's it for now. There's no point in putting the airbox on without the air filter. Luckily, I did reach out to the guy I bought the inverter from and asked if he had his air filter still. And he did. So he's going to throw that in, no extra charge. So I was a little bit concerned that this light would not be compatible. You know, even if it fits physically, it most likely is the wrong voltage. I had assumed that this was controlled by the inverter module itself, and it's not. According to the wiring diagram, it's connected directly to the 120 volt circuit, and that's what this requires, 120 volts. So it should be as easy as cutting this one out, connecting these wires to here, and then we're done. And it looks like it's a good fit. If I had connectors like this to attach there, probably be the easiest thing to do. But in this case, I'm just going to reuse these wires and these connectors, so that way if someone needs to replace this light in the future and they actually get the proper light, it'll be an easy fix. Call me paranoid, but I'm putting a little electrical tape on it as well. A few things showed up in the mail today. I've got the battery tray, the used but good battery, air filter, and of course, the star of the show here, the inverter module. Now, I'm still waiting on the cover for the inverter module, but we have enough here that we can put this together and get it started and make sure that everything checks out. These inverters are not identical. Pretty close. You know, this old one here, we have power in, power out, throttle control, and this is the status lights and eco switch. The new inverter, for the most part, looks to be identical. You know, we have the power in, power out, throttle control, and eco switch and status lights. But there are 2 extra wires here, and those go to this long connector, and I don't see where that would go on this generator. And my best guess is that that provides a boost. This model, it's the EF3000iSE, and the inverter is supposed to be tied into the start battery. So if there's a surge, it can actually pull some power out of the battery, up to 500 watts to handle that surge. And I'm guessing that's what this is for. And this generator is supposed to have that, but I don't see any of the wiring down to the battery for that. So thinking we'll be okay emitting this, but we are going to lose 500 watts of surge on that. Well, that was a bit disappointing. I thought for sure this would fix the problem, and I think it would if I had gotten the right inverter. So I think I made a mistake here. I definitely made a mistake here. I thought I had an EF3000iSE. This model is actually an EF3000iSE, no B. And the B stands for boost. It's a whole separate module. It connects to the 12-volt battery, steps the voltage up to 190 volts DC, and then feeds it into the inverter. And my assumption is that the inverter would work without that, because there are scenarios where you would have a dead start battery and you pull start the generator. But as we just saw, that didn't happen. So either this is in fact a bad module, which it could be, or we need that boost module. And I'm thinking that we do, because there's another connector here. And that was present on the old inverter board, but it was capped off and not needed. Turns out that connects to the missing boost module. Most likely it supplies it with power and allows communication between the inverter and the boost module. So my theory is that the inverter was waiting for the boost module to come online and report its status. And of course that's never going to happen. So I have two options here. I can return this inverter module. There's a 14-day window where I can do that, or I can double down and buy that boost module from the same seller. He most likely has it. So I'm going to message him, see how much he wants for that, and I'll turn you back on in a second. I've got bad news to report. The person I bought this inverter module from did have the boost module, but he already sold it, and there's nothing available on eBay or anywhere else on the used market. They do sell the boost module new, but it's $1,000, and that makes no sense. So this is going to get uninstalled and returned, and I'm going to go to plan B, which is a long shot, admittedly. But after watching the first video, a subscriber named Alan reached out and said he has experienced depotting stuff, that he does it all the time. Nothing quite like this, but this module is bad. He cannot make it worse, and maybe he can work a miracle. So I am going to send it to him. We'll give it a chance, and I'll turn you back on in a second. I got the inverter back today, and according to Alan, the depotting went really well for the 5 minutes that he did it. And then he saw something important that I did not see. So we both agreed that he should just stop and send it back and repair what he saw. And maybe, just maybe, we don't have to actually depot this. And there's a look at the progress that Alan made. This is about 5 minutes of work, and as you can see, there's a lot of work to be had on this. But the point is, it is possible to depot it. He was using boiling water, and once it reaches temperature, you can scrape the stuff off. It turned chalky and came off pretty easily, I'm told. Anyway, the reason why he sent it back, you can probably see it, is right there. That is the three-phase input to the inverter, and it is damaged. You can see the red and white wires. We got bare copper, and those most likely were shorting against each other or the frame, and that would definitely cause an issue. So I guess the question I have is, what caused that? There was a mouse in there. I'm not sure if it looks chewed. I don't think it melted. It could be abraded. I'm not sure. But overheating alone would not have caused this, because there's actually broken copper in that white wire. So I'm going to repair these wires. We'll give this inverter one last chance. And if by some miracle it actually works, then we can move on. I don't think a mouse did this. The location of the damage lines up perfectly with the corner of that bridge rectifier. And I looked back. When I first opened this up, that is where that wire was positioned. And if you look closely, you can actually see evidence of arcing right there. So I think that's what did it. Just no insulation in a spot where it needed some. As far as the repair goes, I guess the correct way to do this would be to cut this back, depin this, and reconnect this connector just a little bit further in. But I don't have these pins, and I think it's kind of redundant anyway, because this wire harness just goes right through here, and it comes out down here to another quick disconnect. So we really only need one, so I'm going to cut these off. We'll connect it directly, which brings me to the next problem. There's not enough wire to do that. So I do need to get this harness out of here and go direct to the inverter. It might fit. Let me try putting it back through. Yeah, that'll fit. What do you think? Will it work? Place your bets. Personally, I think the damage is already done, but let's see. It did a lot better than I thought it would and actually performed the best it ever has. You know, it started right up, the power came on, and the light bulb was actually quite steady, both with the economy switch on and off. It's never done that before, but it still couldn't spin the fan on that space heater. It was heating the elements like before, but we don't have a good AC sine wave coming out. Just to validate that, I am going to hook up the oscilloscope one more time, see if there's any improvement on that sine wave, but I have a feeling, just like what we saw before, is that on the high side of the sine wave, it just flattens out. So it's basically DC on the positive side, and then on the negative part of the sine wave, it looks a lot more like AC, but even that got quite a bit noisy under load. So let's see if there's any change. That actually was better than before. Last time, the bottom part of the sine wave, when under load, looked pretty bad, but this time it was perfect. The top part, it's still flat, and that is our issue. So there is damage in the inverter. I'm sure it's a bad MOSFET, probably a few bad MOSFETs, and unfortunately, even though we've made progress, there's no way to fix that unless it's depotted. So, I guess back to plan B. I'm going to ship this back to Alan, if he still wants it. Now that he's seen it, he may have changed his mind. But my main concern here is that this tape is covering something, and it's not flat. You know, the PCB should be flat, so it's making me wonder what's going on here. Is there another layer of potting underneath the tape? I don't know. But if there is, then yeah, I'm not sure that we're going to get too far. But it can't hurt to try, because it's broken and it's not going to fix itself. So we'll send this off and see what comes of it. Well, guys, I just want to update you on plan B. A few months have passed. I sent that module down to Alan to depot, and he's been flat out with issues going on at work and home, and just hasn't had a chance to depot it yet. Although he says he will, but that gave me some time to think here, because what's the end game on this? I want to repair this and sell it to someone as a reliable generator, and depotting that module successfully, it's a long shot, and an even longer shot is affecting a repair that I feel good about. So I called him off. Really, the proper thing to do here is to part this out or buy the new module. And no matter how I crunch the numbers, buying the module just doesn't make sense. I estimate this is worth $900 in running condition. The module costs $1,200, not to mention I already have some money in this with the battery, the air filter, and the oil change. So I think I would be about $400 short of breaking even if I bought that module. So I'm kind of out of options here. I hate parting stuff out or throwing it away, but it really is starting to look like that is my only option. But there is a plan C. And if you've made it this far in the video, you probably know what that plan is. YouTube does allow me to put advertisements on my videos, and I usually don't do that on new releases, but this one I'm making an exception to, because by watching this video, you're all helping subsidize the repair of this generator, and I estimate after a couple months I should have made enough to at least break even on this repair. So I'm going to conclude the video at this point. I'm going to give it a little bit of time, and with any luck, there'll be a short part 3 installing a new module, testing this out, and putting it all back together. So I hope this video helps someone. Thanks for watching.